Hello student, let us see the different things in swimmer river problem. First different cases are there. Let us take different cases. Now case 1 will take case 1 when swimmer is swimming perpendicular to river, right? Now we can write down the velocity of swimmer with respect to ground can be written as velocity of swimmer with respect to river plus velocity of river with respect to ground. Suppose the swimmer starts swimming perpendicular to the river. Let us take the river is flowing like this. This is the river velocity, I can say VRG, right? And swimmer starts swimming perpendicular to the, I can say this is perpendicular to the river flow. Now if this is the situation, you will observe if somebody is on the ground, he will observe the swimmer is not going in this direction, but swimmer will reach somewhere at this place on the opposite bank. Now this will be the direction of V swimmer with respect to ground, right? Now I can find out in this what time it will take to reach on opposite bank. The time t it takes to reach on the opposite bank. Suppose d is the width, I can write t equals to d divided by VSR. Now this is velocity of swimmer relative to river, or velocity of swimmer when in still water, or velocity of swimmer when river is still. So this is VSR. Now I can write, I can find out the time, this time it will take, and if x is displacement on opposite bank, I can write down x will be equal to VRG into t, and VRG, t is nothing but it is d by SR, right? So this way I can find out displacement on the other bank. Now another type of case when swimmer is making certain angle, where swimmer is swimming making certain angle with normal to the flow of river, or you can say or the river flow. So case 2 will discuss. Case 2 when we swimmer makes some angle theta with VRG. Now if this is the situation, we can find out, you can see here, suppose this is river flow, right, VRG, and this is normal to the flow of river. Let us say a swimmer is swimming in this direction, VSR. He makes theta angle with the normal to the flow of river. Now we can find out what time it will take here. So you will observe the two component of VSR will be in this direction. It will be VSR cos theta, and in this direction it will be VSR sin theta. Now let us take, if we draw the parallelogram, let us take the swimmer is reaching at this place, right? And x is displacement here from just opposite bank. Now I can find out the time, what time it will take to cross the river. T can be written as, if this will be the value of V swimmer with respect to ground, right? And let us take, this is angle alpha. Now I can say here, very simple, I can say the component of this one, VSG cos alpha can be written as VRG minus VSR sin theta, and I can say VSG sin alpha can be written as VSR cos theta. Now to find out the time it takes to cross the river is d divided by, I can say the direction, in this direction what is the component, I can write VSR cos of theta. Now from this you can find out the least time. What least time it will take to cross the river. Now before that we'll see what is this x. Now x can be decided as, x is written as, the horizontal component is Vsg cos alpha, or you can write Vrg minus Vsr sin theta into t, and t can be written as Vsr cos theta. This can be decided at its displacement. Now the least time it takes to cross the river. How to find out the least time? How to find out the least time? I can take this expression t equals to d divided by Vsr cos theta. Now t is least. T is least when cos theta is maximum. And what is maximum value? This is 1 and theta is 0 degree. Now I can find out then T least will be equal to d divided by Vsr only. Now in this situation what will happen? The swimmer will be always flowing. You can take this is Vrg, and this will be direction of Vsr. You can say Vsr, and he will be reaching in least time. He will be crossing least time, but he will not reaching just opposite to his start point. He will be reaching somewhere here. Why? Because this is the direction of Vsg. Now if I want to find out this angle is alpha, this is x, I can find out this x as Vrg into T least, and that can be written Vrg into time is dy Vsr. Right, this is the thing. Now case 3, I can take case 3 when swimmer wants to just reach the opposite bank. Just reach the opposite bank. Now if you just want to reach opposite bank, then what you will observe, this x will be 0, this will be equal. Now just to reach opposite bank, he should make certain angle theta with the normal to the flow of river. Then only now in that situation I can say this will be the diagram, vector diagram, VR river flow, and this will be direction of, you can say, swimmer with respect to river. This angle, this will be the Vsg. I can draw the parallelogram now. This will be the parallelogram, this will be Vrg, right? And here this, let us say this angle is theta. So if you just want to reach opposite bank, these two component Vrg should balance Vsr. Now I can write Vrg should be equal to Vsr sin theta, and T will be equal to d divided by Vsr cos theta. Sin theta can be obtained from this, and T can be decided. So these are the three situations we have seen. How to find out the time to cross the river, this time, and how to find out where he will reach on the opposite bank. That displacement x can be written like this. Now let us see 3-4 problems are in SC Verma. Let us see how to solve those problems and how can we find out the value of unknowns. Now if you take question number, if you see the